So I'm having a bit of a play with the green screen functionality that I'm using on Zoom. So I'm recording this on Zoom and going to give it a go. But anyway, today I'm going to be talking about running costs and energy consumption. A lot of people get in touch with us and they have a dream to do a house, and they say they want it energy efficient, they want to be environmentally friendly, and their first thought is to, often, you know, I want solar panels, I want a heat pump, I want rainwater harvesting, etc. And what we first start by saying to people is, well, the first thing we look at is to try and get the amount of energy you need in the first place down as low as possible. And once we've got your energy consumption to be as low as we can get it on heating and power, then we look at the appropriate ways of servicing that heat demand and heat requirement, or energy power requirement. So some of that knowledge has come from us monitoring our house ever since we built it. So yeah, we've been monitoring stuff and doing graphs and all sorts of things on our house ever since we moved into it in 2009. So it's given us a huge amount of data. Lots of sensors that were built into the house, working with Cambridge University, various bods and boffins that have kind of picked apart various aspects of lifestyle, energy consumption and building physics, energy information. It's been very helpful, and it's sort of embedded it into our design process and the way we design and build our buildings. So today I'm just going to share with you some of the things that we have learned from doing some of this monitoring, and to do it, to have a bit of fun with it and turn it into a bit of a quiz. I've been doing this in lectures and things for a while now, but hopefully it works using this green screen technology. But we're going to look at some things that, you know, pretty much everyone's got familiarity with, got in a house, and we're going to look at see how your how well calibrated your understanding of energy consumption might be. Let's start with this one. So every house has got one of these, a broadband router, sitting in a cupboard somewhere, sitting on top of a cupboard somewhere, ticking over and connecting us to the outside world. And I asked a simple question: how much do we think it costs to run one of those a year? Normally I'd have an audience here and shouting back various answers to me, and those answers typically, you know, vary from, you know, £5 to 20 quid, 50 quid, sometimes as much as 200 quid has been said, which seems an awful lot of money for your broadband router. You wonder what your electricity consumption everywhere else might be. But anyway, have a think, pick a number. Oh, you could always, I suppose, if it's going to go on YouTube, put it into the comment section. Let us know what your answers were, or whether you found it informative. So broadband router, £11.30. Obviously, it slightly depends on what your tariff rate is for your electricity, but a broadband router is a piece of kit that is running at about 9 watts, there or thereabouts, and it's running 24/7 typically. It's not advisable to turn your router off for other technical reasons, but your router tends to just sit there and it's ticking over and it's consuming, in the end, 79 kilowatt hours of energy a year, £11.30. So you might think to yourself, oh, okay, it's only £11.30 per year, I'm not going to worry about it, which actually fine. But there you go, £11.30. A little bit of, that might reset whatever your answer was. It might change the calibration of your mindset from what you perhaps originally thought. But we'll move on to another device that we'll all have, a mobile phone. Now, I don't know about you, but when I go to bed, I've got a charger by my bed. It's plugged into the wall. I never turn it off at the wall or anything like that. I go to bed about 10:30. I plug it in. It sits there, and then I wake up at 6, 7 o'clock. Unplug it, and then get up and get on with my day. Probably quite typical, and everyone can relate to that. So I do that. I've monitored that for a period of 3 months or so, then extrapolated it across a year. So have a think. How much do you think it might cost to run a phone or charge a phone per year? There we go. 35p per year. 2.44 kilowatt hours of energy per year. Now, most times that I ask this question, 35p isn't around about the answer. Sometimes, you know, a fiver, again, maybe 10 or 20 quid. And sometimes their answers have been calibrated by what they learned about the router. But the phone's an interesting one because everyone's got a mobile phone. So it's one of the few devices that we have quite a close connection with energy consumption. So we're constantly, you know, if you've been on the phone all day, you know your phone's going to be low. So that heightened awareness, I think, usually causes people to think that the actual cost of running a phone is going to be a lot more than it is. But it's weird to think that 32, one broadband router actually consumes the equivalent of 32 iPhones over a year. That may be a surprise to you. It's obviously not using a lot of energy. When you plug your phone in at night, it's using about 3 watts for about 40 odd minutes, and then it's basically not consuming anything. So it's a very low consumer of energy. So moving on from the mobile phone, I'll find the next slide. So we like our cups of coffee. We've got a coffee machine in the office, a coffee machine at home. Get up in the morning, cappuccino for me and my wife. And then when we get home or at lunchtime, there might be coffee as well, coffee in the evening. We like our coffee. How much do we think it costs to run a coffee machine for a year? We've done the same thing, measured it for a period of time, and then extrapolated it out. £6.44. So the interesting thing about a coffee machine is it's using about 1800 watts when it's actually making your coffee. But what it's doing is it's heating up a very small amount of water, just the amount of water it needs, and it's forcing that through the coffee, obviously giving you a nice cup of coffee, warming up some milk, steaming it, whatever. But it's using a high wattage of energy, but for a very short period of time. And then if it sits on standby, it's using less than a watt, and if it's off, obviously it's off. But it's interesting to think that a coffee machine is actually using half the amount of energy over a year as the router, a router that's just sitting in the cupboard and you kind of just forget about. But the difference is when you've got any wattage that's running 24/7, the numbers get bigger much more easily. And something like a broadband router becomes wattage that you call part of the baseline of energy consumption in your house. And it's always good to try and think about minimizing ways of getting your baseline amount of energy down as low as possible, either by turning things off or just not having these kind of parasitic type loads that are kind of constantly running. But hopefully, yeah, helpful little bit of recalibration on that one. Now we're going to just slightly shift the emphasis away from kind of electricity, power and running costs in that way, and have a look at how we relate some of this to CO2. Now, I started doing this quiz several years ago, probably as much as 10 years ago. And what's really interesting, I've been updating it recently. And what's really interesting is over the last 10 years, the national grid has using so much less carbon per kilowatt hour. It was over half a kilogram of CO2 per kilowatt hour when we first built our house. And now we're down, you know, it's like 0.56 of a kilogram CO2 per kilowatt hour. That doesn't mean much to anyone. But anyway, that number's now down at sort of 0.22, 0.24, that type of thing. It's less than half. So every unit of energy off the grid is much greener, if you like, than it was 10 years ago, which is great. And it's going to continue to get better. So I've had to redo this slide because it changes some of the dynamics. But the question is, we don't really think about the CO2 footprint of a broadband router. So I'm just going to relate it to something we do know about. And cars, obviously cars have got, they generate CO2 through burning hydrocarbons. I'm using an example here of a 2-litre diesel Land Rover Discovery Sport. And I'm asking how far you can drive this car for it to generate as much CO2 emissions as a broadband router would be generating from taking electricity from the national grid. Let's assume it's all electricity from the national grid. Obviously, if it's home generated energy from solar, it will have a lower CO2 emission. But let's assume you haven't got solar panels, you're getting all the electricity from the national grid, and how far can you drive the car for it to generate as much CO2 as the broadband router? Oh, the answer is, and this one's an interesting. Sometimes people say when you turn the key to turn it on, when you drive to the end of the driveway, 1 mile, 2 miles, 5, 10 miles. Sometimes people throw out, you know, bigger distances. But now, 10 years ago, the answer to this was different. But now, interestingly, it's 75 miles. You can drive a 2-litre diesel car 75 miles for it to generate as much CO2 as the broadband router generates in a year, even at this lower decarbonised grid rating of today, which is quite interesting. That you might think that I'm saying that therefore cars are good. That's not. I'm not saying cars are good. They're still generating huge amounts of carbon, and there's other sorts of emissions and particulates, etc. That are bad for the environment. But the point is actually to say that electricity as a resource is really precious, and it's got still quite a high carbon footprint. So if we can generate electricity, or can reduce the amount of energy electricity we need, or be responsible about how we generate it, it's a precious resource, and it can go a long way to actually reducing our collective carbon footprints. So hopefully that is a helpful little introduction to some aspects of energy consumption. I'm planning on doing lots of different videos to talk about various ways we've been going about our work designing and building buildings to be low energy and be low emissions, low embodied energy, low operational energy. So there's plenty more videos to come, but this is one of those things that I've been doing in lectures for a while, and I thought you might enjoy. So thank you very much. If you've got any comments about that, if you found it helpful, do let us know on the YouTube channel. If you want to subscribe to our channel, please do by clicking somewhere over here, and another video should pop up over here somewhere about some other aspect of the work we're doing on energy conservation, or might be paragraph 79, or aspects of building new houses in the open countryside, things like that. But if you've got anything you'd like to discuss with us, get in touch, and I hope we can help. Hope you found that useful. Thanks so much. Take care. Bye.